assigned to the fifth speaker, the radial shearing interferometer for reconstruction of wavefront by fringe modeling, Mr. Hui Wu from Seoul National University of Science and Technology.
Hello everyone, so my name is Hui Wu. Currently I'm a PhD student in Seoul National University of Science and Technology. And I'm here today to present to you guys about my topics, the radial shearing interferometer for reconstruction of the wavefront by fringe modeling. So I divided my presentation into 4 main parts: introduction, methods, verification, and conclusion. Let me start with the first part, some introduction about my topics. So the people all the way keep moving to understand the world around you, to take a record around you. A good quality image is needed, is necessary for a lot of application, like the photography, physics, biography, and even aerospace. But nowadays, it's a minimize of the device is a chance, like a smartphone camera system. Like a compact system is needed. So as you know that in this case of imaging system, if using the spherical surface, a lot of the aberration can be happen, which is like the distortion happen in the image here. So it can be overcome using the aspheric surface. But the problem is, to measure the aspheric target is always a challenge for all of the optical engineering and any researcher in this field. So a method with accurate, effective, simple, fast, and even flexible is needed for this field. And today I propose a method, a novel method, to measure the aspheric surface using the non-known measurement, radial shearing interferometer. So let me detail about my method. So the radial shearing interferometer will be conducted by using the beam splitter, the 3 mirror for the loop, standard loop, and the pair of the lens with the different focal lengths. So the wavefront under test here will be defined the horizon of 45 degrees here and split into the beam splitter with the red part is the demagnification part with the vertical horizon state. And the transmitted part is the blue part, magnification part, and the horizontal horizon. Please focus on the red part. So the wavefront under test from here reflected in the beam splitter and passing through the lens 1, lens 2 respectively, and one more time reflect at beam splitter and going out the interferometer. And the second part is the blue part. The blue part transmitted into the beam splitter and passing through the lens 2, lens 1 reversely with the first part respectively, and coming out the beam splitter one more time transmitted in here. In output of the interferometer, we locate the quarter wavelet at 45 degrees in here. So 2 orthogonal polarization state in here will be converted to the left circular polarization and right circular polarization, and both of that overlap each other and make the interferogram. The advantage of the radial shearing interferometer is the reference-free property. The demagnification part wavefront and the magnification part wavefront will be getting closer if the shearing amount between the 2 lenses is very small, and the small departure in here can be provided. Remarkable in this configuration, the 2 different beam size will be generated by using the RSI system. So the smaller departure by reference free will be controlled by the shearing amount between the 2 lenses. And the last one, we will single shot measurement using this configuration by polarization cameras. And we just discussed previous. So the right circular polarization and left circular polarization is the material for the dynamic interferometer. Dynamic interferometer is nothing but just using the polarization camera. In the surface of the camera, we mask 0, 45, 90, 135 degree linear polarization state. That means if the polarization angle provided by alpha, so the phase shift between the left circular polarization and right circular polarization provided by double of alpha. So let's see here is the 4 interferogram with the phase shift 0, 90, 180, and 270 degree phase shifting respectively with the polarization angle provided here. Let's consider that the 4 interferogram can be represented by mathematics I1, I2, I3, I4 respectively with the different phase is 90 degree. On here, the phase shifting technique can be applied effectively by subtract between the I4, I2, I1, and I3 and take arctangent for the ratio between the phase will be detected. But unfortunately, this kind of phase, because of here is arctangent function, so the return phase is interval of the minus pi and pi. So we have to continue that phase to detect our target. So unwarping process will be text. Unwarping process is nothing but just will be text from subtract or minus the 2 pi for each periods of time. The most effort in my research and the key technique in here is the fringe model method. So let me explain about that by using that kind of flowcharts. I divided my flowcharts to 2 parts, experiment part, left hand side, and the modeling right hand side. In this case of experiment part, I just explained that I using the 4-bucket algorithm to get a wavefront arrow by 4-bucket algorithm. And in the modeling, we using the 2 individual configurations to represent the 2 arms of the interferometer. And by subtract between the 2 wavefront in the 2 configurations, we get the different wavefront. By compare between the wavefront arrow in experiment and modeling, we will get a good agreement between them. In here is the most description about my flowcharts. The constraint in the modeling will be updated and optimized, so we get the good agreement by this. But let's access the one person to get the good agreement for this point. Okay, to verify our method, so we conduct one experiment in this way. So the beam, plane wave beam come from the collimator, split into BS, get information from the ASPEN target, and split on here, beam polarizing beam splitter, and coming back to the cameras. So in this case, polarizing camera can be captured directly 4 pictures simultaneous. Similar to the experiment method, so I propose the fringe modeling by ray tracing software by using the 2 individual configuration, and after that I get the interferogram. So briefly comparison, the interferogram in here and the 0 1 I mark in here, it could be temporary look together. So the target I apply to measure in this configuration I provide by the table here. So this is the data flow charts to see detail about my proposal. The modeling is interferogram I just told before. The experiment with the 4-bucket algorithm. So we will get this kind of phase from the 4 image we capture from the polarizing camera. After I taking an unwrapping process, the continuous phase will be get by comparison between this and this. In optimization process, so we will get a good agreement between experiment and modeling. So here is the optimization result. Before we optimize, so 2 parts different between the experiment and modeling, and after that I get a good agreement. And take one comparison between our method with the commercial product to measure our surface. We will get a different PV around 6 and RMS around 1 nanometer. Finally, so with this kind of the novel methods, we hope that we can apply our method to a lot of the techniques now in the industrial. So the radial shearing interferometer can be applied to measure the aspect. This is the key target to, we hope that. And on-machine measurement can be measured by signal source only. The fast, the precise, the flexible, and the simple methods for non-known measurement will be generated, and the absolute surface profile can be detected by optimization process. And finally, so nanoscale measurement precision will be demonstrated. Before I close my topic, so I would like to say thank to the PR project to support me to complete that research. Thank you so much.
Have any questions? No, please. Okay, then. I have a simple question. So in reconstruction of wavefront, the typical way is to use the modal reconstruction or the zonal reconstruction, and I think your method is a kind of the modal reconstruction. Why do you use a GMAX? I mean, the typical way to do that is kind of using the ionic polynomials to describe the aberrations, and what's the base thing in the GMAX?
Actually, a lot of the researchers are trying to generate the algorithm to reconstruct the wavefront as you mentioned, but actually in my case, so we trying to modeling by using GMAX to representing of the experiment. So we trying to get the exactly experiment set up by using the GMAX. But where the good agreement is, okay, that means we will looking for the experiment set up now, and this is the result express.
Thank you. And once again, do you have any questions? Okay, and then let's thank to the speakers again. Okay, let's move to the next speaker. Optical depth measurement for microgroup asset interferometry method based on near-field polarization analysis from Tokyo University of Tokyo.